Factor sum and difference of cubes. So we have two examples. One is for difference of cubes, the other one is sum of cubes. And let us see how to factor such polynomials. So difference of cube formula is a cube minus b cube is equals to a minus b times a square plus ab plus b square. And the sum of cubes formula is a cube plus b cube equals to a plus b, a square minus ab plus b square. Correct? That's the formula. Now in the given question, what we can do is we can write them as cubes. Now 125 is 5 cubes, so I can write this as 5 cube. This is 125, and x to the power 15 can be written as x to the power of 5 cube. Do you see that? So that is how we can make them cubes, right? And the second term, 216 is 6 cube. Better way of writing is 6, and 36 divided by 3 is 12, 6y to the power of 12 and whole cube. Right? This is a preferred way of writing. Correct? So what we get cube difference of cubes. Do you see that? Let me rewrite this. So I'll rewrite this as 5x to the power of 5 whole cube minus 6y square whole cube. Do you see? So the given binomial can be written as difference of cubes. Now we can factor this using our factor equation, right? A cube minus b cube is a minus b. And what is a for us? In this particular case, a is 5x to the power of 5 and b is 6y to the power of 2. That is b. So let's use the formula and factor. So we can write this now as a minus b, that is 5x to the power of 5, that is a, minus b is 6y to the power of 12. That becomes the first factor, and the second factor is square of this, which is 5 square is 25. X to the power of 5 square will give us 10. Plus ab, just multiply them. 6 times 5 is 30. X to the power of 5, y to the power of 12, plus square of the second term, which is 36, y to the power of 24. So that is how you can factor such difference of cubes or sum of cubes, correct? Let's do the next one now, which is x minus 3 whole cube plus y plus 2 whole cube. It's already written as sum of cubes. Let's apply the formula. So the first factor for us is sum of these two, which is x minus 3 plus y plus 2. And now we get square of the first term. So let me write it in a different ink within this bracket. Or, well, let's continue. We get x minus 3 whole square minus ab, minus of the, we have to multiply these two terms, which is x minus 3 times y plus 2, and then we have to add square of the second term, which is y plus 2. So that is the second factor. Now let's simplify and write it down. So we get x plus y minus 3 plus 2 is minus 1, and in this case let us expand them. We get x square minus 6x plus 9. Here we get x into y. Let's write them in brackets, negative xy 2x minus 3y, and then we have minus 6 plus y square plus 2y, rather 4y, 2 times 2 times y, plus 4, correct? So that becomes the second factor. Now we can open these brackets and simplify. We get x plus y minus 1. So x square, there is no other x squares, we have x square. Minus 6x, let's look into these terms. So minus 6x plus, which is also minus, these are the two x terms. So minus 6x minus 2x gives us minus 8x. Then we have the terms like xy, so which is minus xy. And then we will take terms like y's. So we have minus 3y. So let's look for the y's first. And plus 4y. That means plus y. Let's look for y squares. Y square is just 1 plus y square. The constants. We have 9 minus 6 and 4. We have taken this term also. Plus 9 plus 6. Plus 9 plus 6 is 15. 15 plus 4 is 19, right? 19. So we've taken care of almost all the terms, I think so. So that's how we get. In fact, I did one mistake. Minus and minus becomes plus 3y. So we get plus 7y here, not just y. So we have plus 7y. So let me correct this part. I hope others are correct options. But the whole idea here is that we have sum of cubes. You can apply the formula, right? Expand them, simplify, and then get your answer, right? So that is how we can do sum and difference of cubes for questions which are kind of complicated, right? So practice with some of these questions. I think that should be fine. Thank you and all the best.